We actually did have some questions about your experiences. We thought your work was really interesting and we want to learn more about you and yeah, more about your journey. So yeah, like I said, it's nice to meet you. I can call you Dr. Joshi.
No, you can call me Sid. I also don't
Sid.
even have a PhD yet, so
Okay,
yeah.
okay, okay. Okay. Sid's fine. Thank you. All right. Yeah, so could you tell me a little bit about yourself and your journey in like computer science and data?
Yeah, sure. So, one second. Let me just find a better place to put this down. Yeah. Oh, never mind. Yeah, so I essentially I did my undergrad at UCLA in starting 2015 in computer science, and then UCLA has this department of scholar program, so I added like a master's along the way at some point.
Hmm.
Um, I graduated um, early 2021, like in I think March or so, and then started working for Microsoft for a year and a half as a software engineer. And then that puts us at September 2022, and that's when I went back for my PhD. And now I am doing my PhD. I just finished my second year,
Right.
and I have done so last summer I was at Cisco. This summer I'm at Microsoft Research. So that's where I'm at right now, actually.
Nice. Awesome. So so what initially like sparked your interest in I know right now you're working with data, it seems, and so what initially sparked your interest with, computer science in general, and how did that evolve into your more focused interest in data or what right now?
Mm-hmm. I don't fully remember what sparked my interest in computer science. I think I've kind of always been interested in um, computer science. Mostly, I think it started out more like with maths, and then slowly built into um, the algorithmic side of computer science. And
Mhm.
then over time, I also liked that it was kind of fun to build stuff. And I always liked building I guess software stuff because uh, I like working with code rather than physical objects.
Right.
That's just my
Hmm.
preference.
Hmm.
Or pen and paper rather than physics for the physical objects. So I think computer science was a cool way. I mean, computer science is also hardware, but my particular interests were a cool way for me to um, play with things that build things in
Right.
software. And,
Right.
that
So
stuff.
you're interested in the coding and the programming aspect more than the hands-on type style.
Yeah, initially, and then over time, then I kind of lost as much interest in the software engineering part of it, and was interested more and more in um, the fundamentals of computer science. I did some research in cryptography, distributed algorithms, etc., and then eventually settled around machine learning because there it's I get to do math stuff, which is what I
Mhm.
really enjoy. Um, and then I also get to implement things at times, which is fun, and then I get to see the I guess practical impact of that, which is sometimes harder to see with other research.
Right. Right. Cool. So, um, yeah, we were really interested in your work, and one of the papers that we saw that you recently worked on was it's titled it was around prioritizing data quality and over quantity. So I was wondering if you could give us just like a brief overview of that research.
Okay, yeah. So that's basically what my thesis is about, data efficient learning.
Hmm.
And the idea of data efficient learning is that we the biggest cost these days in training these large models is that you have a vast amount of data and just making a pass through all that data or multiple passes through all that data takes very, very long.
Hmm.
Uh, but what we try to do is okay, cool, maybe all the data that is not useful. So what we do is we mathematically formulate what subsets of data are most useful and then come up with algorithms to select those subsets. And then we show through experiments that look, actually, if you just train on the subset, you get the same performance as training on the full data, and
Hmm.
sometimes even better. Um, and so that's sort of the core of the work. That
Right.
particular work that you're talking about. So I've done this, my focus, for these approaches is for methods of learning that don't require labels. So
Mhm.
like traditionally machine learning had like a supervised learning framework where you had some data and you had some labels.
Right.
Um, but recently we've seen like a bunch of like self-supervised methods become very, very successful. Like contrastive learning is one of them. And my
Mhm.
first paper was on data selection for contrastive learning, or general like single modality self-supervised learning, you can say. My second paper, the one that you're referring to, is on multimodal learning. So if you're familiar with CLIP, that's what OpenAI trained. It's like an image caption matching model. So you like
Right.
give it an image, you give it a caption, and it tells you how similar these two things are
Mhm.
in concept. And so my subset selection approach allows you to train like a CLIP model like much, much more efficiently
Mhm.
in this regime. So that, yeah, that's the one I think you're talking about.
Right. In the sense that if you took not the whole data, but a smaller section of that data,
Yeah.
and you reference that you mathematically formulate that.
Yeah, so essentially, like for the paper you're referring to, like what we show is that if you train on data that has like these certain properties, then what you can guarantee is that the model you learn will be similar to the model trained on the full data.
Mhm.
And if I can go, like I can go into a little bit more detail there, if that's interesting.
Yeah,
So
sure.
in
Go ahead.
particular, we're talking about like the cross covariance of the data. So you can think about cross covariance of data intuitively for image caption data as being like how do the objects in the image vary with the keywords in the caption.
Mhm.
Okay, so like how does like changing that object change the keyword in the caption?
Right.
And that we can actually mathematically formulate using one of these models in their embedding space. So we can take like a lightweight model, one that's like trained on a random subset or like trained for a very little time. So it's
Mhm.
very cheap to get embeddings of our image caption data from there, and then compute this mathematical quantity of cross covariance, and then select a subset that such that that cross covariance, like this relation between how objects in the image vary with captions in the keyword changes, like something, a subset that preserves that quality.
Mhm.
What we show is that if you can do that, you can guarantee that the model you learn is the same as the model on the full data. And then we also show how you can do that. Like, how exactly do you find that subset? Because
Right.
um, this is like a non-trivial problem. Like potentially you could be selecting every single subset and checking if this
Mhm.
property holds, right? But that doesn't work because that's exponentially hard. Like you have 2 to the n subsets.
Yeah.
So you have to have some sort of like smart approaches into how you can select this in like a greedy way so that you can take it like one example by example and not have to really consider the whole subset, but actually still pick a subset that as a whole is good.
Right. Yeah, so that's an important finding, and also being able to replicate that and explain how you did that is also really important. And I think that's fascinating. So what are some of the like challenges that you tackled in solving that problem?
Right. So I think there's like many challenges that come up in like a project like that. One of the first ones is like when you start out, you really don't know. It's hard to start in a vacuum, like mathematically, and say like this is what I believe to be a good subset.
Hmm.
And luckily, this work builds upon my previous work, so I had some good ideas
Right.
starting with this. But for the previous work, like I had no idea as to what would be a good subset.
Mhm.
So initially, that involves a lot of like guesswork and intuition about like, hey, I think these kinds of examples would be good. Um,
Can you give an
and then once
example?
I have like a guesswork kind of baseline, then I start to build from there. Like,
Mhm.
is like I go and check, is that guess hypothesis really true? And
Okay,
then if
okay.
it, then I try to like find out like, okay, cool, like this was a guess, but like what am I formally really like trying to get at here?
Hmm.
And then it's an iteration back and forth, like you guess and you define your hypothesis a little bit, like try to make it a little bit more mathematical, a little bit more formal, and then you like evaluate and like you evaluate in the sense like here train a model and then check if it's good and see that.
Right.
And yeah, so that's like the main approach. And one of the other main problems in these kinds of research, or like any research really, but especially research that involves training models, is that you need to have like efficient ways to like check if your hypothesis is true. So you need to have like nice, like you have to have small models that behave the same as your larger model would, and small data sets that behave the same way that your larger data sets would. So ensuring that the whatever you're testing or iterating on quickly will scale is also super important.
Hmm. Hmm. Right. Yeah, those are two very important issues. So expanding off of that, there's currently like a large, I don't know, like widespread interest in fairness in machine learning. How can you like what are the ethical considerations that you take in that data selection process, right? You're making a mathematical model. So how do you ensure that you're retaining the fairness of AI systems in that sense?
Yeah, that's a good question. So like I have some other work that focuses on this problem. Like we refer to it often as like the problem of spurious correlations, where like some attributes might be spuriously correlated with some things, but they're not causally linked to them. For example, like gender bias in some like employment data, right?
Mhm,
Uh, so the algorithm I just spoke about, these kinds of algorithms, their guarantees are about just preserving the properties of the full data. So if the full data has this problem, most likely it'll be there in the subset as well.
mhm,
But in practice, like when these systems are deployed, like you don't only use one of these algorithms, you would also have like a separate sort of algorithm to like ensure the fairness. So you would first perhaps try to I guess you could do it either way, but you could first select a subset, like some like a small version of your like data set, and then apply some of these fairness methods to ensure that like um, you balance all the different groups and like give them all importance in the data in the subset that you did select.
mhm. Right. Okay. So, and then backing away from that, like more specific question and speaking more about balance, just kind of a general question for you. I know your work is on efficiency through data, but what are your like just general thoughts on a balance between developing more sophisticated AI like model structures or techniques and making the current ones more efficient via better data selection?
Yeah, so I'm not sure if I fully understood the question, but I think what you're trying to get at is that like, what do I feel about like data work versus model work?
Right. Hmm.
Okay. Yeah, so like clearly, I guess since I'm doing a PhD in like data selection stuff, so I am like kind of biased here,
Yeah.
but probably what people have observed recently is that data work just seems to be much more high leverage. Like you can do there's a lot more to discover on the data side, and it seems to have a much more profound impact on your models than simple strategies like changing then changing the architecture or like coming up with very complex like loss functions, etc.
Hmm.
Like what it turns out is like pretty much with any reasonable loss function and reasonable architecture, you can learn anything. It just comes down to like the data.
Hmm.
That's not to say that like model work's not important. Like you still have to like it's because we've made so much progress in model work that we're able to like do this today.
Right.
um, but like for the foreseeable future, it does seem like the data side of things is much more important.
Okay. And then are there any specific like industries or applications where you see like data efficient learning being like the next big thing, like very transformative to that industry? I understand that it's definitely a big thing and will help a lot of, general AI and machine learning will advance because of this, but just like any specific fields where this kind of logic will be significantly helpful in relation to others.
Um, yeah, it's hard to think of like a specific industry because like almost all all of the industries that we know end up having like a surplus of data. Off the top of my mind, I can think of like perhaps so the one that's like why this is most useful for like general model development is like for general model development or models that are generalist, we use like all internet scale data, and that's
Yep.
the where this problem exists in the extreme, right? Like you have genuinely infinite data, and you do need to select because you can't train on the full data.
Yep.
So that's where it's most important. Ideally, it should also be super important in healthcare because we have a lot of medical data, but practically, I guess because of all the legal sort of red tape around using medical data, like in practice, people don't usually have access to vast repositories of medical data. But let's say that were to get like resolved, like medical data is another place where like significant benefits can be gained from like
Mhm.
selection and not training on all the data.
Right. So it's particularly transformative in those fields where there's a lot of data and you want to retain all the insights that you can get from that
Yeah,
data, but it's too computationally expensive to train with all of that. And you
exactly.
want, okay,
Exactly.
right.
Yeah.
That makes sense. Okay. And then just some more things about you personally. So I noticed that you have experience and you talked about your experience with Microsoft, Cisco. So given your experience working in both academia and in industry, what are some of the key differences or similarities you've noticed in terms of like approaches or goals and challenges and just like how you think, I guess, in those different scenarios?
I see. Yeah, so I think um, it like the thing is I can make some broad comparisons between like industry, software engineering, and research. But to make a statement, I guess, about like industry research and academia research is really hard. And the reason is that the way research works is it's often done in like a small group. So every small group kind of works differently.
Hmm.
Um, so in my experience, my academic group has been much more like while we do while like our focus is still empirical work, we always have like a slight theoretical flavor to our work.
Hmm.
But in industry, there have been times where that's not the focus. Like we focus more on the empirical side, but that could just be the team or like the project I'm working on, right? Like there's also people in industry who do a lot of theoretical work.
Hmm.
So overall, it's like really hard to like say anything concrete about the two. Um, So yeah, I would just say like it really, really depends on the group and you can't really predict from the outside.
Right. How would you like how would you consider collaboration between those two groups, like an industry small research group versus a an academia small group?
Like how is collaboration
Yeah,
treated in
would
a
you say there's a
setting?
difference?
Uh, yeah, that's a good point. Good question. I would say in my experience, um, industry groups tend to have actually okay, no. So industry groups tend to have like very clear guidelines around who and who you can't collaborate with
Hmm.
because it has to be within your team. But like within the team, it's very flexible, right? You can collaborate with literally anyone on the team
Right.
on a project. Academia is different. You technically have no rules around who you can collaborate with. You could
Hmm.
collaborate with anyone. But that also means that like sometimes it just doesn't happen because you don't have like a fixed group of people to like collaborate with. Like you usually
Right.
will just be collaborating within your lab.
Right. No
Um,
incentive to go and reach out to other people. You can
I
just do
mean,
it.
there is incentives. Like, but it's just not as easy to do. Like, you know, you have to go to a
Hmm.
conference, meet someone, or you need to have a
Right.
friend, like a colleague at some other workplace, and then end up collaborating with them.
Right.
In industry, it's like even if you're put in a team, right, and the team tends to have like some sort of unified goal, which is also what a lab is in academia. But the academic lab can be slightly more loosely connected
Hmm.
than industry labs.
Right.
So sometimes you may not be able to collaborate with your lab mates on a particular project because that's not their forte.
Hmm. And yeah, that's pretty much all my questions were about industry and research. Just like maybe one question to wrap it up, kind of. I know it's getting to that kind of time. But what advice, as a high schooler interested in data, machine learning, all these computer science terms, what advice would you give to like aspiring students, as a PhD? What advice would you give to those students interested in pursuing such a career in AI, data, machine learning?
Yeah, yeah. I think it's a great time to be interested in this stuff, and like there's gonna be a lot more work in this field. I guess my advice would be to really, um, yeah, to really like get your hands dirty and try out stuff yourself. And like because some of like while not all of the researches you can kind of test and verify on your own, like a lot of it you can actually do on your own these days. So it's always good to just play with that stuff.
Hmm.
And the second thing is like earlier on in your like sort of academic journey, it's super important to explore. So you don't want to like while it would be great if you knew exactly what you wanted, like if you want to do a PhD, potentially it'd be great if you knew what your thesis was going to be tomorrow because you could start building
Right,
towards
right.
um, but that's unlikely, right?
Hmm.
So you kind of have to explore a lot. And I would say like at a high school stage, like the next 4 year, like the next couple of years, like just explore really intensely. Like
Hmm.
figure out what you like by trying a bunch of different things. And
Right.
then once you know that, you can start to like specialize. But yeah, I think the first thing, like the main thing I would say is like don't specialize too early.
Mhm.
Yeah, because you want to like enjoy your work.
Right, right. Okay. Well, that was very informative. I really appreciate your time,
Yeah,
Sid. Thank
I'm
you.
glad. Yeah, yeah.
Yep.
Thank you.
It's great that we actually got to meet. Thank you.
Yeah, I'm glad. Yeah.
All right.
Cool.
Bye-bye.
Yeah. Bye. Best of luck.
Bye.